So welcome everybody to this latest video on 162 Maths, and in this video we'll be going over some GCSE Maths Higher Revision past exam questions on reoccurring decimals. Now as always we'll be going through a series of past exam questions, so if you're wanting to have an attempt at those questions before watching through this video as we go through the answers, then all you'll need to do is just simply click on the link in the description below. Now before we get started, it's really important that you're able to convert the different types of recurring decimals into fractions. Now to learn this, or if you are unsure, there is a link in the description to direct you to the lesson covering how to do this. Now before we get started, you may want to practice converting the following decimals. So if you want to pause the video to have an attempt at working these out, you can do so right now, and let's have a look at what answers you should have. So looking at the first one, if you've done this correctly, you should get the answer of 2/3. For question 2, if you've done this correctly, you should have 32/99. For question 3, you should have 41/90. For question 4, you should have, as it's a number that's bigger than 1, it should be an improper fraction, so that's going to be 7/3. And for the last one, you should have 196/45. Now the thing to remember is that with most of these questions, they will appear on the non-calculator paper, as a lot of modern calculators now can convert it straight away by simply typing in the decimal number, pressing equals, and it'll automatically give you the fraction in its simplest form. So it's a good way of practicing making up your own questions, is to just mess around with your calculator and doing it algebraically. Now before we get started, a little reminder that if you're wanting to have an attempt at these exam questions based on recurring decimals, then there is a link in the description for you to download and have an attempt at, which I strongly recommend you do before watching through these videos as we go through the answers. Now you will notice that a lot of these questions are very similar to the practice questions, because there really isn't much variety you can get when working with these questions, but sometimes they can carry a few extra marks depending on if there's a little extra thing that you need to do, like simplifying or working with multiple recurring decimals. So let's have a look at question 1. So question 1 says convert 5/6 into a recurring decimal. Now for this, we're going in the opposite direction to what we typically do. So here we're going to convert this into a decimal. Now one way of doing this is to do some division. So here if I do 6 goes outside the bus stop and 5 goes inside, and what I'm going to do is just add a few zeros. So here 6 into 5 goes 0, so I carry the 5. Then 6 into 50 go 8, it's 48, remainder 2. 6 into 20 goes 3, remainder 2. And then it's going to be 3, and I'm going to constantly keep getting a remainder of 2, therefore giving me 3. So here 5/6 is going to be 0.383. Let me just write that again. 83 recurring, and there is my final answer. So in here I would write it as that. Moving on to question 2, it says prove algebraically that we've got this. So looking at this, we want to prove algebraically that 3.747 recurring equals 313/90. So again, what we're going to do here is just go through the steps. So working with the decimal. Now you could go from the fraction to the decimal number, but the question says to prove it algebraically. So here long division would not help. So, and that's why they include this statement of proving it algebraically. So we have to go from the decimal to the fraction. So here if I make the decimal equal to x, now what I want to do here, just to go over the method, is I want to try and rewrite this statement so that I've got the same number of numbers after the decimal point in both lines. Now here if I multiply by 10, then what I get is 34.7 recurring. And again, if I take away those two things there, I've got the numbers after the decimal point are different, so that's why that's not going to work. So what I need to do is try and find another equation. So if I multiply the original number by 100, both sides by 100 in fact, then what I get is 347.7 recurring, and this is what I'm going to be using. So from these two, if I just rewrite it, it's not essential, but again, you may have some errors in your working out if you don't include any negatives, is 347.7, and I'm going to end up with 10x equals 34.7 recurring. And what I then want to do is take away those two. So 100 take away 10x is going to give me 90x. And then here, what I then want to do is do the takeaway. So here it's going to be relatively easy because the top number is bigger. So it's going to be, well, this is going to cancel out. So here I've got 3, 1, 3. And then from this, take the 90 over. So I've got x equals 313 over 90. Then it's just a case of trying to work out whether this does simplify, and it doesn't. So there is my final answer. Well, actually, in fact, that's what it's actually asked me to prove. And there I've done it algebraically. Moving on to question 3, it says circle the fraction that is equivalent to 0.1 recurring. So again, either you know these or you don't. But here, if we just went through the steps, I've got 0.1 recurring, 10x is 1.1 recurring, and if I do 10x take away 1x equals, let's make that a little bit better, 1.1 recurring, 0.1 recurring, that becomes 9x, that becomes 1, so it's going to be 1 over 9 equals x, which is my first answer. But again, if you're happy with these, usually what you find is 0.1 recurring is 1 over 9, 0.2 is 2 over 9, 0.3 is 3 over 9, etc. So moving on to question 4, we can notice that this question is very, very similar to the second question. So here it says prove algebraically 2.75 recurring converts to the fraction, and here we've got a fraction. So again, make it equal to x. Then we multiply by 10. So we've got 27.5 recurring. Then obviously you can see that the number of decimals, well, not the number of decimals, the number after the decimal point is not the same. So I need another equation. So let's multiply it by 100. So that becomes 275.5 recurring. Then I can use these two equations. So let's just move that over here. Try and put the biggest equation at the top, just so that you're not having to faff about with negatives. And then we've got 27.5 recurring. So then all I'm left to do then is just simply take the two things away. And so what I should end up with is 90x equals 275, take away 27, which gives me 248. Take the 90 over to the other side. So I'm left with x equals 248 divided by 90, which simplifies to give me 124 over 45. I'll leave that as an improper fraction because that's what it's asking me to show. Moving on to question 5, it says use the fact to show, so here we've been told that 0.7 is 7 over 9. Use this fact to show that 0.07 recurring is 7 over 90. Now here, what you want to notice is that 0.7 recurring divided by 10 equals 0.07 recurring. Because again, when you're dividing by 10, you're just moving the decimal point one place to the left to make it smaller. Now, if I convert these two numbers here into fractions, and what I get is this is going to be 7 over 9 using the fact divided by 10, and I'm going to convert that into a fraction as 7 over 1. Now let me just make that a little bit clearer. And so from this, what we then do is, knowing our rules of dividing fractions, we flip the second fraction and turn it into a multiply, and that then becomes 7 over 90, which is exactly what they wanted me to prove. Moving on to question B, it says hence or otherwise, using part A or otherwise, convert 0.27 into a fraction. So again, what I'll do is I'll do the otherwise. So again, we've got x equals 0.27 recurring. So again, multiplying it by 10, we get 2.7 recurring. The numbers after the decimal point aren't the same, so I need another equation. So that's going to be multiply both sides by x by 100. So then we get 27.7 recurring. So then using these two, what I get is 100x equals 27.7 recurring, 10x equals 2.7 recurring. I take the two lines away, so I get 90x equals 25, and x equals 25 over 90, which does simplify to give me 5/18. Now another way you could do it is looking at this is, well, we know that 0.27 recurring is equal to 0.2 plus 0.07 recurring. Now this as a fraction is 2/10 plus we've been told that 0.07 is 7/90. So then if you try and convert this into adding fractions, so we need a common denominator, so we multiply this by 9, so we have 7/90, so that then becomes 25/90, which simplifies to be 5/18. As you can see, we both get the same answer. So whether you use your answer in part A or you just do it afresh, you should still come out with the same answer. So moving on to question 6, you can see here we've got again a very similar question to our previous one. So here we want to express 0.15 recurring as a fraction in its simplest form. So here if we write the decimal number is equal to x, then we multiply that by 10, so we get 1.5 recurring. We need another equation because the number after the decimal point is not the same, so if I multiply that by 100, I'm going to get 15.5 recurring, and it's going to be these two equations that I then need to use. So from that, if I jiggle them around, I get 15.5 recurring, 10x equals 1.5 recurring, and we want to take away. Now again, just going over what we know is you want to try and get to a point where the reoccurring decimals, when you subtract, cancel each other out. So here I'm going to end up with 90x equals, they cancel out, so 15 take away 1 is 14, so x equals 14/90. Then we can simplify this because they're both factors of 2, multiples of 2, and that then becomes 7/45. And just always make sure that your 7s look like 7s and not 1s. Moving on to question 7, again, very, very similar to the previous one, so I'll just go straight into working this out. So we want to convert 0.28 as a fraction, 0.28 recurring as a fraction. So then from this, we get that, multiply it by 100, and we get 28.8 recurring. Then again, using these two, we get 100x equals 28.8 recurring, and 10x equals 2.8 recurring. Take the 2 away, 90x equals 26, so x equals 26/90, which is 13/45. Then moving on to question 8, again show that 4/9 is equivalent to 0.4. Now again, there's no mention of the word algebra, so you could either go from the decimal to the fraction, or you could go the fraction to the decimal. It's entirely up to you, but seeing as we've done this already, let's just quickly do it algebraically. So now we have got the same number of numbers after decimal point, so I don't need to multiply it by a further 10 to get 100x, so it's just going to be 10x, take away 1x, and that's, oh no, that one is 4.4 recurring, that's 0.4 recurring. Take the two equations away, 9x equals 4, so x equals 4/9, which is what they wanted me to show. And again, alternately, what you could have done is done 9/4, add a few extra decimals. So here, 9 divided by 4 goes none, carry the 4, that's going to go in a 3, no, it's going to go in 4 times, remainder 4, and then 4, remainder 4, 4, 4, and that's going to continue. So therefore the answer then 0.4 recurring. So either way is going to be absolutely fine. The next question then says, using part A or otherwise, write 0.94 as a fraction. So I'll do the first one where we're not using part A. So again, x equals 0.94 recurring. Multiply it by 10 and we get 9.4 recurring. Multiply that by 100 and we get 94.4 recurring. And then 100x equals 94.4. 10x equals 9.4 recurring. Take the two things away, and we get an answer of 90x equals, and it's going to be 85, so x equals 85 over 90, and we can simplify that fraction as 17 over 18 by dividing both numbers by 5. Then if we were using the answer, then what we've got is 0.94 recurring equals, and if I just remind myself to what the original number was, 0.4. So here, this is going to be 0.9 plus 0.04 recurring. This is going to be 4 over 90 because we want that extra 0, and this is going to be 9 over 10. So then if we get a common denominator by multiplying the first fraction by 9, we get 81 plus over 90 plus 4 over 90, which equals 85 over 90, which equals 17 over 18. So our final answer, whichever way you prefer to do it, is going to be 17 over 18. Moving on to question 9. Again, here we want to convert 0.172 recurring into a fraction in its lowest term. So again, we make it equal to 0. And note that only the 72 is being recurring. So if you multiply that by 10, we get 1.72 recurring. Then if we multiply that by 100, we get 17.27 recurring. And then if we multiply that by 1000, we get 17272 recurring. Now, from this, the reason why we had to go a little bit extra is, as you can see, we're looking at the decimal numbers, which numbers have the same numbers after the decimal point. So what we have to use this time are going to be these two equations. Now, it is possible you could have gone to 10,000 and that would be the same as 100x, but we're going to go for the most simplest way, the quickest way of doing it, which is going to be using those two lines. So here we've got 1000x equals 172.72 recurring. Then we're going to use 10x, which is 1.72 recurring. If I take the two things away, I end up with 990x equals 171. So therefore, x equals 171 over 990. Now the next thing for me then to do is just to double check to make sure that that simplifies, and it does. So I can divide both numbers by 9. So it's going to be 19 over 110. Now if you're not sure about whether it would simplify, well, I definitely know that this is going to divide by 9 because 900 goes into 9 and 90 goes into 9. For this top number, if you add up the digits, it equals a number that's a multiple of 9, and so therefore 9, there's a good chance that 9 could be divided. So all you then need to do is just test it by doing 9 divided by 171, and you will end up with an answer of 19. So here our final answer is going to be 19 over 110. And just make sure that that doesn't look like a 6. And there we go. Now moving on to our last question. The question says to calculate 0.2 recurring plus 0.48 recurring, writing your answer as a fraction in its lowest terms. So for this, what we've got to do is we've got to do exactly what we've been doing in the whole video virtually twice. So here, looking at this first number, I've got x equals 0.2 recurring. So here 10x equals 2.2 recurring. So 10x equals 2.2 recurring. X equals 0.2 recurring. Take those two things away and end up with 9x equals 2. So x equals 2 over 9. Then with this second one, I've got x equals 0.48 recurring. So 10x equals 4.8 recurring. 100x equals 48.8 recurring. Then using these two lines, what we end up with is 100x equals 48.8 recurring. 10x equals 4.8 recurring. Take the two equations away, we end up with 90x equals 44. So x equals 44 over 90. Now from this, what we then want to do is, using these two answers that we have, is then from that take this over here. So we've got 0.2 recurring plus 0.48 recurring. And I'm going to not simplify. I could easily have simplified the second one, so I could have had 22 over 45, which I can do. It's not a problem. I will use that one. So from this, what we can then do is convert this as 2 over 9, and we'll convert this as 22 over 45. Now the next thing for us to do now is we're adding fractions. So when you're adding fractions, we need a common denominator. So here, if I multiply this entire fraction by 5 over 5, we then get 10 over 45 plus 22 over 45. Don't worry, I've wrote an equal sign there, so let me just get rid of that. And then that then becomes 32 over 45. And then it's just to check, can I simplify that particular fraction? And the question is, no, I can't. So there is my final answer. Now, if I did use 44 over 90, then there is a good chance that I could have then simplified. But because I simplified earlier, it meant that I did have to do that much simplifying later on in the question.